we must find the area of a square, PQRS. In a square, all four side lengths are equal. To find the area of a square, we take our side length and we square it. The main issue here is that we don't know the side length of our square. Let's label this unknown with x. So, how can we find the value of x? Well, let's try to fill in some more information into our diagram. We know that the length from A to B is 7 centimeters. If A to Q is 5 centimeters, this means that there'll be 2 centimeters left over for Q to B. Now, we can exploit some symmetry in the outer square. B to R, C to S, and D to P will all be 5 centimeters also. R to C, S to D, and P to A will all be 2 centimeters. To find the value of x, we can use Pythagoras' theorem. This states that in a right-angled triangle with a hypotenuse of C and lengths of A and B for the other two sides, C squared is equal to A squared plus B squared. Let's zoom in to the bottom left corner and focus on the triangle APQ. Since we're told ABCD is a square, the angle at A is a 90-degree right angle. The hypotenuse is defined to be the side opposite the right angle. So here, the hypotenuse is x. The other two sides are 5 centimeters and 2 centimeters. We can apply Pythagoras' theorem with C equal to x, A equal to 5, and B equal to 2. Let's sub these values in. 5 squared is 25, and 2 squared is 4. 25 plus 4 is 29, so we end up with x squared is equal to 29. To find the value of x, we need to get rid of this square. The inverse of a square is a square root, so to get rid of this, we should square root both sides. On the left-hand side, the square root and the square cancel, so we end up with x being equal to the square root of 29. Now that we know the side length of a square, finding the area is straightforward. All we do is take the side length and square it. So here, the area of PQRS will come out as the square root of 29 all squared. The square root and the square will cancel, so we'll get a final answer of 29. The lengths in our square were labelled with centimetres. Areas are always presented in square units, so our unit here is centimetres squared. The formula for the circumference of a circle is found on page 8 of the formula book. It says that a circle with radius r has a circumference L given by L is equal to 2 pi times r. We'll use this result 2 times to find the circumference of the circle U and the circumference of the circle V. U has a radius of 4 centimeters. So here we'll put in a 4 for r. 2 times 4 is 8, so this gives us an answer of 8 pi. We're asked to give our answer in terms of pi, so we shouldn't convert this to decimal form. Our unit here is centimeters, since that was what was used for the radius. Circle V has a radius of 6 centimeters. So here we'll substitute in r equal to 6. 2 times 6 is 12, so the circumference of V is 12 pi centimeters. In part I, we found that the circumference of V is 12 pi centimeters. This means that if you drew a line along the boundary of V, the length of this line would be 12 pi centimeters. This means that one full rotation of V corresponds to a movement of 12 pi centimeters. It follows that 100 rotations of V would correspond to a movement of 12 pi times 100. This comes out as 1200 pi centimeters. Since our wheels are in non-slip contact, every bit of movement in V will cause the same amount of movement in U. This means that U will also undertake a total movement of 1200 pi centimeters. All we have to do is figure out how many rotations this corresponds to. Well, the circumference of U is 8 pi centimeters. This means that it takes a movement of 8 pi centimeters for one full rotation of U. So, we have a total movement of 1200 pi centimeters, and each rotation takes 8 pi centimeters. To find the number of rotations, all we have to do is divide these numbers. 1200 pi divided by 8 pi. Performing this calculation gives us our answer of 150 rotations.